That's okay. So I will describe. I will repeat the my talk after Maghrib prayer. But so if you have the benefit because you will uh, see this twice. Okay, basically what I want to say is about basically we already cover. Okay, uh, did I share my screen? I think I have to share entire screen. Share, share. Okay. So basically, in the previous meeting, I already covered what uh, AI, the large language model, and the last class is more about process mining. So now I will talk about the more on big data, how we can process. Basically, we'll talk about machine learning and deep learning. But in those things, the tool we are going to use basically two tools. Orange data mining. It's free. This is free. This is the simplest tools for new students to play around with machine learning, deep learning, and those kind of stuff. It's quite simple. So the programming is graphical programming like this. Let me see. This is Wikipedia. So the programming is like this, very simple. Uh, I highly recommend to learn about these things through Orange Data Mining first. After getting the ID, then we can move into Python. Okay, so basically Google Colab. Google Colab. So this is basically Python. Okay, so like this. Let me cancel this so we can play around with these things. Okay, there is make it bigger. I have there are several menus here. We have getting started menu, data science, and machine learning. Basically, okay. The coding, you can see the coding somewhere here. For example, let me see if I can see something more complicated. For example, this is this one, linear regression with Keras using synthetic data. So you can see the source code here. Let me see if I can see the source code. See, this is the source code. It's import something, and then we can show the code. This is the code for creating the model and so on. So basically, this is basically Python. Okay, but don't worry about this thing. This looks very complicated. But to make it simple, I recommend to use this one, Orange. The actual code is actually similar. Basically, on the back end of Orange is Python, so it's basically similar to Python. And this one is much more easier to play with. Okay, but I like to give you some idea about the philosophy behind these things. Okay, okay. Most of these things is used basically, especially in Keras, or is using neural network. Basically, in Keras we use for AI, we use neural network. Okay, we can see neural network something like this. Okay, so in Orange as well as in Python, we can define how many nodes, how many hidden nodes, and so on, what kind of activation function we are going to use, and so on. So we can set up something like that in the neural network. What is neural network? Many people talk about it's very similar to brain, neural, and so on. But basically, when I do the coding, when I code these things, Then I learned it's basically it will solve this kind of equations. Let me make it bigger. The equation itself is very simple. Is oops, sorry. Okay, so it solved this equation. Ax plus b is equal to y. So it solved this equation. Okay. Okay. I like to ask question to you guys. What kind of equation is this? The type of equation. What is the type of equation is this? Can you write it down in the chat box? Okay. Let me see. Okay, let's check the chat box. What is the equation? What kind of equation is this one? Ax plus b is equal to y. Did I share my screen? Let me see. I will try to share again. Present something. Show screen anyway. Okay. Linear? Right. So Pak Wira Pratama correctly mentioned this is linear. How can we see the linear equation in neural network? I will show that here. Okay. Let's see. So neural network is like this. Okay. Let me see. Okay. So this is the neural network. Where is the linear equation here? Doesn't see any linear equation here, right? Okay. To show you the linear equation there is something like this. Neural network ax plus b equal to y. Okay, so the equation, this is linear. Let me see if I can show you something much better. Or this one. Nope, this one. The easiest one is, let me find something much easier to see. Where is the linear part? This one or this one? Oh, okay, I will start with this one then. Okay, this one. I think I'm in trouble. Okay. Let me see if I can show the linear part. Let me change this one. ANN is artificial neural network. Wrong. Okay, no. Okay, this one is the closest one. Okay, let me see. Cool. So we have a neural network like this. Actually, the actual math is nope. Where's that figure there? No. I have to go back again. See this figure here. So basically, so if we have one neuron here, it will collect the input from many input. This is input number 1, 2, 3, and so on until input, what this is, M, R, N, I don't know. So this is X1, X2, X3, and so on. And this is W1, W2, W3, and so on, Wn. So basically, X1 multiplied by W1 goes to the neuron. X2 multiplied by W2 goes to neuron, and so on. So basically, this is X, this is A. A goes to neuron, and we have bias here. This is B. So the equation is a x1 a1, x2 a2, x3 at. So x, there we have many x here, and all sum, and we have b bias here, also sum with the rest of it. And in the linear equation, we don't have this one activation function, and the output is y. So basically y equal to a x1 is equal to the sum of this one, of these things. Okay, so this is basically linear, except this one, activation function. Activation function basically filtering the output based on our demand. Basically, you can have linear. Maybe later I will describe about this activation function. Basically, we have this linear equation here. Okay, maybe I can describe something on the equation function. So basically, if it is linear, it's basically x1 w1 plus x2 w2 plus x3 w3 plus x4 w4 plus b as the output. But then the output is filtered by this one activation function. What kind of filter we can put here? There are a lot of filter here. Okay, let me find the activation function here. Activation function in neural network. Okay, so we have many activation function here. Where is it? Okay, the figure is not big enough. Okay. Oops. Okay, so here we have several activation function. Okay, I can see it. So this is activation function. This is the y. The vertical axis is y. The horizontal axis is x. So this is not linear. So for example, on this one, LU, for positive x value, the y is we have y. If it is negative, we have a slight nearly zero y, but there is not zero. So this is the value here. This is the value on this part. Okay, on this one, this is the value on this part. On this one is log. So this. So LU, swish, SELU, soft plus, mesh, RLU, hand switch is very similar to one another, but little bit different. This normally, if we are dealing with linear or what linear value in y. So the value is what's that? It's not classification. It's more for prediction and stuff like that. So this is not for what's that? For classification. If we are seeing this kind of value, sigmoid, soft sine, tongue edge, hard tongue edge, hard soft sigmoid, these are for classification. For example, yes, no. So y value may be only two values, yes, no. So we use this kind of value. So if it is a classification problem, normally we use this one. If this is a linear problem, we use this one. These things is basically to solve any non-linearity in the what's that? In the data. So if we have a lot of linearity, if we put this kind of filter, it help to reduce the unlinearity in the data. So the convergence of the algorithm is much easier using this kind of filter. Okay, so the filter is basically to do those things. Okay, so we put this. And how do we know which one we use? Basically, it's trial and error. We are trial and error to do these things and to see which one is the more correct one or more precise one. So we do trial and error on this one. Okay, so that's about, most of the time we use ReLU. Many times we use ReLU, but for classification function, we sometimes, let me see if I can find any. So this one, ReLU, is the favorite one. If it is classification only, sometimes we use this one, sometimes we use this one. Okay. On this one, the output is from minus to plus. On this one, from 0 to 2. So it's different. So this is more positive value. This is from minus 1 to 1. Okay. So this is for if you want. But all of this basically, when we choose which one is which, we normally play around with it and see which one will produce more accurate results. Basically, that's okay. So we play around with it. So okay, now it's 6 o'clock. So we'll break for like what, 10-15 minutes for Maghrib prayer, then we continue. Okay. Thank you very much. So I will break for a few minutes. Let me see. Okay. How can I disable these things? Stop presenting. Okay.